We talked about modeling objects, modeling relationships. We can't call this done until we finish talking about modeling inheritance. Inheritance is a very powerful concept, but one of the most overused concepts in object-oriented programming. It has some really good advantages when it's used for the right reasons. We'll talk about quite a number of things with inheritance, but also talk about it in relationship with other relationships we talked about. Inheritance models a relationship which is a relationship or a kind of relationship. We typically say that here is a particular abstraction and we want to create another abstraction that extends from that abstraction. The real reason for using inheritance, in my opinion, is to really reuse the code that is using an abstraction. So for example, somebody who knows how to drive a car should be able to drive other types of cars as long as we can have that kind of inheritance model. Well, often in a statically typed language, we rely upon inheritance to reuse the code from the base class and to substitute the object where it is being used in other places. Like, for example, the driver driving a car should be able to use different types of cars. So in a sense, we have two somewhat conflicting things going on here. One is to reuse the content of the base class, and the other is to be used in place where the other object is being used. Well, polymorphism kicks into a great extent when it comes to that usage that we will discuss again in other principles and practices later on. When it comes to inheritance, we have a base class and we also have a derived class. The base class is often also called as superclass. It's all super, meaning it's superlative. It's really a generalization. A derived class, on the other hand, or a subclass, is more of a real specialization, if you will. So the base class provides some general concepts, behavior, abstraction, implementation, potentially. The derived classes provide a specialization or something that really gives an alternate implementation, if you will. While it can give an alternate implementation, the external behavior of the code should be consistent with the behavior that the base class actually provides. Inheritance is transitive. If a class inherits from a base class and that class inherits from another base class, then the child class here inherits from the grandfather class or the grandparent class, if you will. So inheritance is transitive. You inherit from the base, which inherits from another base, and that keeps on going. Which means this derived object can be substituted for any class in the hierarchy that's basically provided by inheritance. When it comes to inheritance, this transitive nature, even though it's very powerful, is fairly restrictive. For example, let's say we have inheritance, and the way we're going to have inheritance is, let's say we have a class called vehicle that inherits, a car that inherits from vehicle. Let's represent that in the code for a minute. So let's say class vehicle right here, and I'm going to have a class called car, which extends from vehicle. If this was C++, you would say public colon, or rather colon public. In the case of C#, you would say colon instead of extends, but the concepts are pretty much the same. You are inheriting a car from a vehicle. Now this is transitive, so car inherits from vehicle, and if vehicle inherits from something else like object, car also inherits from object. That's a transitive nature we talked about. But when everything is said and done, inheritance is pretty static. We decide at compile time often what class we inherit from, and we are stuck with it. So car inherits from vehicle, we are done. There are tools that allow us to vary the implementation of the inheritance, but languages often don't directly support it. They are usually third-party tools that mess with the code manipulation at runtime or at post-compilation times. But ignoring those, we have inheritance, which is pretty much static. But on the other hand, if you compare that to aggregation, we have a lot more power with us in aggregation. Aggregation could be fixed, variable, or recursive. What does that really mean? Well, let's talk about fixed aggregation. I have a wallet. That's a fixed aggregation. I carry one wallet with me, and that's a fixed aggregation. I own my wallet, and it's pretty much fixed. So in that case, you could argue that's pretty much a fixed aggregation. On the other hand, we could have a variable aggregation. A variable aggregation is where I could have multiple objects, like for example, the vehicles I own. I got a few vehicles I own, and that's a variable aggregation. I could buy another vehicle, I could get rid of the vehicle I have currently, and so on. That's a variable aggregation. I got a pool of objects I could switch among or add more objects, remove objects, and so on. That's a variable aggregation. Recursive aggregation is where the aggregation is like inheritance is transitive, but aggregation is recursive in that you aggregate an object which in turn aggregates another object, which in turn, and this could keep going on and on and on and on. So that's an example of a recursive aggregation. For example, a folder containing files is a variable aggregation, whereas a folder containing a subfolder is a recursive aggregation. So in other words, what you have is, let's say you have a folder F1 and it's got a file 1 and file 2. Well, that is really an example of variable aggregation. On the other hand, the folder F1 containing folder F2, where folder F2 contains some file, let's say file 3 and file 4 and file 5, but it also contains another folder F3, wherein that folder in turn contains potentially some files, but also folder F4, which contains folder F5, and so on and on and on. So that is an example of recursive aggregation where what you aggregate in turn aggregates, and this can keep on going. Well, inheritance is pretty transitive in one direction and static. Aggregation is very dynamic in that you may stop aggregation at any level, reattach aggregation. Tomorrow you can come back and add 2 more folders to folder F4. So folder F4 contains 2 children, F5 and F6, where F5 and F6 may again contain other children. You can come back and add tomorrow, remove, and manipulate it. You can also decide what type of folders they are. You could decide a type of object you connect to. Aggregation is flexible in that you can aggregate. I could have a wallet, but I could have different types of wallets, whereas inheritance is pretty static. Well, inheritance is modeled as generalization or sometimes as realization, depending on how you call it. And these are purely generalization terms. So for example, we could create a class called a car over here. And we could also create a class called a vehicle, for example, and then we could specify in here that we have a relationship between the car and the vehicle, and you use an open triangle to represent inheritance. So this says that a car inherits from vehicle. So which means all the properties of vehicle are now available in the class car. So a vehicle over here is the base class and car is the derived class. So all the properties, all the methods of vehicle are also available in the car, but car can also have its own methods and implementation and fields. But anywhere a vehicle can be used, we can also use a car because of this inheritance hierarchy. So this is really inheritance. Well, generalization is much more general term where you are trying to provide a generalization, could be an interface, could be a generalization at the component library where you could say here's a bunch of interfaces that are generalization for the bunch of classes that could be implemented in 1 or 2 different libraries. So you could even use generalization at component level. For example, I could say JDBC library is a database access library. It contains a component which gives me database access, but I can have different implementations of the JDBC library. You could say that's a generalization at a component level. So inheritance usually is at a class level. Generalization is a generalization of inheritance. It could be at a component level, could be at a class level, could be at an interface level, and so on. When it comes to inheritance, should my inheritance hierarchy be deep or should I be really broad, where you have one class, a few classes that keeps climbing up and you have 7, 8, 9 levels of inheritance hierarchy? Or do you want to have a class and then you have several derived classes, subclasses, and so you have a fairly flat hierarchy but a lot of these dependencies going to a common class? Well, the short answer is neither one of them is good. You want this to be as thin and short as possible rather than being too deep or too broad in the sense, because inheritance increases coupling, and the more inheritance you have, the worse off we are. If the hierarchy is too deep, it really becomes too hard to maintain this level of coupling. Something that changes way up here could affect something way below here. And also people lose sight of what this hierarchy is once we get beyond 7 or 8 levels. Likewise, if we have a class and have several classes, a change to one of the class can affect many different classes, and that also is a result of deep coupling or a tight coupling. So you want to minimize that as well. When it comes to inheritance, the difference between the base and the derived and what makes one derived different from another is often called the discriminator. For example, human is a base class, men and women, gender becomes the discriminator. Likewise, you could say there is a vehicle, but I could have a bicycle versus a car, and you could argue what the discriminator between those two are. Both of those could be used as a vehicle. One is human powered potentially. The other could be, gasoline powered and so on. Or one could be, going at a certain rate or a certain speed for a certain kind of conditions. Airplane versus helicopter versus a car, where all of these could be vehicles, but they all are different. You can think of the discriminators between them. When it comes to association, aggregation, and inheritance, it's important to understand that association is for objects of the same strata. Aggregation is a has-a or a part-all relationship. On the other hand, the inheritance is more of a is-a or kind of relationship. So these are all different perspectives on how objects come together. However, an association itself is really a object level relationship. Inheritance, on the other hand, is a class level relationship. So for example, if you go back to the example we are working with here, we could say, for instance, we can have a class engine, let's say here, and I could come in here and say engine, and create an engine. So this is an aggregation, or you could also say this is an association, not very different for our discussion point of view here. So either aggregation or association we have for the engine. Whereas we know that in this case we have inheritance over here at the top level. So inheritance is a class level relationship. Aggregation and association are object level. What does that really mean? Well, car is a kind of, or is a vehicle. Car is a vehicle, period, right? No matter what we do, that is set on stone. However, we could have a class here called turbo engine, for example, which extends from engine. Now, the beauty of this is we could have an object of turbo engine referred to by the car. So for example, you could say public car over here, and this could take an engine over here as a parameter, the engine, and then we could simply say, let's say engine equals the engine. Well, you clearly can say a new car, new turbo engine, and notice how a car now can hold on to an object of turbo engine even though it directly does not depend on a turbo engine. That's because aggregation and association are object level relationship. An object of car can hold on to an object of engine, or an object of car can hold on to an object of turbo engine, but a class car inherits from a class vehicle. So association is a object level. Aggregation and association are object level relationship. Inheritance is a class level relationship. Now when it comes to classes, a base class could be also an abstract base class, in which case you cannot have objects of this class, you cannot have direct instances of this class. It's purely used for extending purpose and substitution purpose, but you don't create abstractions of this type, instances of this abstraction directly. For example, human, animal, we don't see a human on the street even though everybody who walks around is a human. So likewise, animals, we don't see animals on the street, but any creature that walks around is some kind of a derived type of an animal. That's basically what it is. A higher elevation of abstract classes is interfaces. While abstract classes can have implementations in them, interfaces don't. So an interface is a collection of contract things you could potentially do. An abstract class cannot have instances like interfaces cannot have instances, but an abstract class can have fields, implementations, partially implemented methods, other implemented methods, what have you. So an interface gives us a much more extensibility by providing a contract with absolutely no implementation bindings, whereas an abstract base class binds us to a certain interface, so a certain implementation rather. So if you want a particular function to be highly reusable, it's better that it depends on an interface rather than an abstract class. That way you can provide multiple different implementations. Let's talk about an example here. Let's say we have a class called car for a minute. So we have a class called car, and let's just start with the car for a minute. And let's say this car is gasoline powered, let's say. So this is gasoline powered. What that means is you're going to have methods like, for example, fill gas, for instance. Now let's say we have a user of this abstraction. So we have a public, let's say, void drive, and this is going to take a car as an object. Well, what does this drive method depend on? This drive method depends on a car, which means that this potentially can say car.fillGas, for example, and use stuff like that. Now tomorrow, let's say we decide to really extend this further. Well, we could get a little creative and say we're going to make this an abstract class called car, and then we could come up with a class over here called, a specialized car. Well, let's call it as, energy efficient car. Well, this extends from car, but it also has methods like fill gas, great. And so we could pass an energy efficient car to the drive method because drive takes a car, and as a result, we can pass an energy efficient car. Well, that's great so far. But let's say for a minute, we decide to create a class called electric car instead of car itself. Now, this is purely electric car, and guess what? There will not be a fill gas function, right? There won't be any fill gas function. That wouldn't exist. Electric cars don't require filling the gas. Well, what do we do now? Well, I cannot send an electric car to the drive function, and the reason for that is that the drive function expects a car which has a fill gas, and our electric car doesn't have any fill gas. So notice in this case, even though we have an abstract base class, it's not very reusable in this case. But let's go back a step further and say interface called vehicle, and where the interface vehicle contains, let's say, a method called refuel. Well, it doesn't say how to refuel, but it gives us a refuel option. Well, we could have a fill gas method in the abstract class, but the refuel could turn around and call fill gas, but that becomes internal. The car figures out how to really refuel itself in this particular case. Pretty fancy, huh? But on the other hand, energy efficient car could simply overwrite the fill gas and be done with it. It doesn't have to have a refuel method. The electric car, on the other hand, would have a refuel because it implements, in this case, the vehicle interface. So does this class car, which implements the vehicle interface. Now, in this case, if our drive method accepts a vehicle as a parameter, then in this case, it would say a vehicle dot refuel, for example. And now, of course, we could pass anything that conforms to a vehicle interface. But the real key point here is, if you inherit from an abstract base class, you carry the burden of its implementation even further. But if you inherit or implement an interface, you don't carry any burden of an implementation at all, and you can implement your version of those functions any way that may make sense to you. Of course, there's ultimately some limits you may run into, but interfaces give you more flexibility than the inheritance through classes and abstract classes give. So the golden rule is, if you have an option between using an interface and using an abstract base class, use an interface instead of using an abstract base class. Well, when it comes to inheritance, as much as possible, we should extend rather than restrict. So in other words, you shouldn't override the methods of a base class and start to throw arbitrary exceptions. You shouldn't override the methods of a base class and do something completely different in behavior than what's expected from the base class. In other words, when we use inheritance, the behavior of the derived class must be consistent with the published behavior of the base class. We'll talk more about this in other presentations later on, but the point is, inheritance is not just putting the word extends or colon and be done with it. We got to pay really good attention to how we are extending and how we are using. In fact, it's so important that we extend and don't restrict that Java decided to use the word extends to indicate that we should be broadening and not narrowing when we inherit. So in other words, a derived class should not restrict or narrow or make things harder than what the base class provides. You should be really substitutable. And if you're not being substitutable, then that inheritance will eventually fail because the user of the base class will have trouble using an instance of the derived class. So for example, if the efficient car was more restrictive than the car, then the user of the car would not be able to use the energy efficient car. So energy efficient car has to be broader than the car. It shouldn't be more restrictive. It should extend it. In fact, that's one of the reasons why in languages like C#, you cannot take a public method and make it protected or private, or you cannot take a protected method and make it. So in other words, you have to consistently keep the access privilege in C#. You cannot change the access privilege. Public stays public, protected stays protected. In the case of Java, though, you can take a protected and make it public, but you cannot make it private. You cannot make it more restrictive. So languages safeguard to a certain extent. We'll talk more about this later on and see how this matters. But for most part, what we refer to in these examples are what are called class-based inheritance. A class-based inheritance is where a class like car, for example, or efficient car extends from yet another class or extends from an interface. So class-based inheritance is what C++, C#, Java, all of these languages provide. So does languages like Ruby pretty much provide class-based inheritance. So does Groovy and very many different languages. However, there is yet another type of inheritance that's available also, which is called the prototypal inheritance. A prototypal inheritance is where we use inheritance, but not class-based, but prototype or prototypal based. A prototype is just another object, so we inherit the features of another object rather than inherit the features of a class. So in class-based inheritance, we inherit from a class. In prototypal inheritance, we inherit from an object. Let's take a look at how that works. Now clearly in this example, let's say we have a class called car. Let's take that for a minute and see the benefits of the two differences here. So let's say we have a class called vehicle, and the class vehicle has, let's say, a method called drive, let's say. So I have a drive method, and within this I'm going to say output, we'll say driving, for example. Now on the other hand, I could say a class called car, and in this case we could say that a car doesn't have anything right now, but it extends from vehicle. Now the beauty of this is, notice that in this case I could create a car object, so we could say car equals new car, for example, and then I could say car.drive, and you can see in this case that it simply calls the drive of the vehicle. This is class-based inheritance. I don't have to implement the drive method in car. I get it for free from the vehicle class automatically. Of course, I could override the drive method in the car if I wanted to, but any method I don't, I get it from the base class. However, the car can only get methods from the vehicle directly. That is basically the class-based inheritance that Java provides for us. Ignoring the default methods available in Java 8, this is pretty much what we have. And even in that case, you are pretty much stuck to the interfaces you inherit, and that's all decided for you at compile time. Well, that's not the case in prototypal inheritance. Let's take a look at an example here in JavaScript. So I'm going to say var vehicle equals, and I'm going to create a class. This is how we create classes in JavaScript. And I'm going to say here this dot drive equals, and this is going to be a function I'm going to create, and I'm going to simply say driving like we just did a few minutes ago. Now I say car equals, again, a class called car. And in this case, I don't have any functions whatsoever. But I'm going to say car.prototype equals new vehicle. So now I'm going to say car equals new car, just like we did in Java. And I'm going to say car.drive over here. So I've called the drive method on the car, and notice that car doesn't have a drive method, but it suddenly came from the vehicle up here. So it's similar to what we saw in Java, but there's a remarkable difference on our hand in this case. Notice what I could do here. Car.proto, and I'm going to say equals, and let's simply define a JSON object with a drive method, which has got a function, and I'm going to simply say a drive faster over here. And now I come back to the class that we have on our hand and simply say car.drive, if you will. And notice in this case, the same car that we are using now ended up calling a different implementation of the drive method. This is called the prototypal inheritance. So in a sense, imagine like me carrying a backpack, and you ask me for something. If I don't have it on me, I can grab it from my backpack and give it to you. Likewise, JavaScript carry a prototype, and with prototypal inheritance, they reach into the prototype if they don't have a property among themselves. So as a result, you notice that when you call the drive method here, it reached into the prototype, which was assigned at the class level to begin with. But then when you reassign the prototype at the instance level, it ended up reaching into the prototype's instance level prototype. So that gives us the ability to use inheritance, but you can see how we are able to vary this inheritance at runtime and say, I want to inherit from this now, I want to vary to this. That's a flexibility prototypal inheritance gives. Static inheritance, class-based inheritance is static. Prototypal inheritance is very dynamic, as we can see in this particular case. That's an example of the prototypal inheritance. Most mainstream languages provide the class-based inheritance, which is fairly static, but there are languages like JavaScript and a few other languages that do provide this powerful prototypal inheritance. So again, when we program with these languages, these are the design options we have on our hand, and we need to pick and choose what may make sense depending on the language capability and also based on our application need. And that's what the fun is, that we can vary some of these things as we please and make use of what makes the most sense.